This is Bob Capetta from the University of Illinois at Chicago, and this lesson is an introduction to vectors. So what exactly are vectors? Well, they give us a magnitude, a length, together with a direction. So these four vectors are all the same, so their location in space doesn't matter. Now, how can we talk about the direction of this vector? Well, if you look at this version, you can see from here to here it goes -2 in the x direction and 5 in the y direction. Of course, these aren't quite to scale, but you see what's happening. In each case, 2 left, 5 up, 2 left, 5 up, 2 left, 5 up. So we're interested in the change in x. How is x changing? From the starting point to the ending point, we're going 2 blocks west, so our change in x is -2. From our starting point to the ending point, what's our change in y? How much has that gone up? Well, that's going up 5. So that's the way we want to think about this. Think about how the point is moving over time. The first component will be the change in x, and the second component will be the change in y. So here's one way for us to write this. We use this angle bracket notation. So -2 is our change in x, +5 is our change in y. But that's not the only way to write it. We can also write it as a column vector. So that is often written this way. So -2 in the first component and 5 in the second component. And we have a third way that we can write these vectors. We defined I as the vector 1, 0 and j as the vector 0, 1. So certainly -2 times 1, 0 plus 5 times 0, 1 will also give us this same vector, 2 to the left, 5 up. So we have multiple notations that we'll use. You need to be comfortable with all of them. As we're moving forward, you'll see we're going to use the column vector approach here first. So we're interested in what we call vector addition, adding two vectors together, and scalar multiplication. Can we scale them, make the same vector larger or smaller by multiplying by a real number, thus scaling the vector? So our first example is going to be u plus v. So how do we add these two vectors? This has 2 blocks west, 5 blocks north. This has 3 blocks east and 4 blocks north, 3 over 4 up. So if you add them together, all you have to do is add the components. 2 blocks west followed by 3 blocks east would be a result of what? Of 1 block east. 5 north, 4 north would be a total of 9 north. But thinking of it this way, we just add the components. -2 plus 3 is 1, 5 plus 4 is 9. So the vector u plus v results in simply 1, 9. Now how about 2u minus v? So scale u, double it. So the same direction, but multiply it by 2, and then subtract v. What will that look like? What will our strategy be? Well, instead of subtraction, I like to make it plus -1, just a little clearer as we do our analysis. So we're going to scale the vector u by 2, doubling each component. We're going to scale the vector v by -1, so changing its direction, pointing in the opposite way, but equivalent to multiplying it by -1, both elements. So 2 times u, 2 times -2, 5, plus -1 times v, -1 times 3, 4. Well, what is 2 times -2, 5? That's what, -4, 10. -1 times 3, 4 would be -3, -4. So now that we're here, we recognize all we're doing is adding the components. -4 plus -3 is -7. 10 plus -4 is 6. And that will indeed be our resultant vector of twice the vector u minus the vector v. Our next discussion is to look at the magnitude of these vectors. How long is it? What is the size of that vector? And you can see that we can just use Pythagoras, 2 over and 5 up. The magnitude of the vector is the same thing as the hypotenuse of the triangle. So we're using this notation again, -2, 5, go 2 blocks west and 5 blocks up, regardless of where you start. Now how can we find that magnitude? What are we going to do? We're going to use the Pythagorean theorem because we have triangles. And using those triangles, we can see the magnitude of u, this guy squared plus this guy squared. I use the negative number here. You could use the positive number. However you're going to look at that, though, when we square it, it becomes positive. So that's 4 plus 25 or 29. So the magnitude of u, the length of u, is going to be the square root of 29. So we know that. So it's important for us to determine what the size of a vector is And we get that directly from looking at the Pythagorean theorem. So that's not too challenging. But the size doesn't tell us the whole story. You could have multiple vectors of the same size. We are also interested in what we call the direction angle. So what is that going to be? We want to find the angle that the vector makes with the positive x-axis measured in a counterclockwise manner. So if we go back here, starting with the positive x-axis, let's say we're looking at this vector, what is the angle measured from the positive x-axis to that vector? It is an obtuse angle. It is more than 90 degrees, and we're going to figure out what that is. So the example I'm going to give you here, we're going to change it up. For our example, we're going to look at 2 root 3 and 2, just to make the computation a little bit easier. So that means go 2 root 3 in the x direction and 2 in the y direction. And how are we going to find the direction angle? Well, here's how this is done in general. All right, we have a vector v. This is the x component, called v1. This is the y component, called v2. If I want this angle theta, the tangent of theta is opposite over adjacent. The opposite is the y value, or v2. The x value is v1. So the tangent of theta is v2 over v1. The way we find our direction angle is to take the arctangent of the second component divided by the first component. So in our case here, our second component will be 2 root 3 divided by 2, and you'll see how to proceed. Check that, 2 divided by 2 root 3. Second component is 2. First component is 2 root 3. So the y value is 2, x value is 2 root 3. 2 divided by 2 root 3 is 1 over root 3. So theta, the direction angle, is the inverse tangent of this. And I always think of the fact that sine of 30 degrees is a half. Sine of 60 degrees is root 3. Check that. Sine of 30 degrees is a half. Cosine of 30 degrees is root 3 over 2. So if you divide those two things, you get 1 over root 3. And the result is that theta is 30 degrees, or theta is pi over 6, arctangent of 1 over root 3. So that's our direction angle for this thing. So 2 root 3, 2 has a direction angle of pi over 6. Now, we want to talk about unit vectors. So a unit vector has length of 1. If I want to construct a unit vector, I take my original vector and divide it by its magnitude, by its length. And that will indeed result in a vector with length 1. So in this example, we're going to let the vector u be negative 2, 5, written in this form, which is column vector form or angle bracket form. And I want to turn it into a unit vector. I want its length to be 1. I want the same direction, but a different length. All I've got to do is divide by the magnitude. So to get that unit vector, the unit vector in the direction of u is u divided by the magnitude of u. So we're going to take negative 2, 5 divided by the magnitude of negative 2, 5, which we showed was root 29 in an earlier slide. So putting this together, the first component is negative 2 over root 29. The second component is 5 over root 29. And that indeed is a unit vector pointing in the same direction of u. Our last topic we're going to look at here in this lesson is the dot product. So we use this symbol that looks like multiplication, but there really is no such thing as multiplication of two vectors. We have to define the kind of multiplication. And in this course, we're going to look at the dot product, which is simply multiply the first components, u1, v1, plus multiply the second components, u2, v2. And that will be useful for us because it will help us find the angle between the two vectors. It can also actually be used to define the magnitude of a vector. The magnitude of a vector squared is just the dot product of the vector with itself. But since we're using the Pythagorean theorem, that'll be sufficient for this course. Let's look at an example. U is 1, 3 and v is negative 2, 5. Can we find the dot product, u dot v? If that's the case, 1 times negative 2 plus 3 times 5. That's what we get. 1 times negative 2 is negative 2. 3 times 5 is 15. We have negative 2 plus 15, and u dot v in this example is 13. And you'll notice that u dot v and v dot u would have to be the same. So that's a good thing to know. The dot product is indeed commutative. But to take this a little bit further, we're going to let theta be the angle between the vectors u and v. And we can find out what that angle is by looking at the dot product. So here's our big rule. U dot v is the length of u times the length of v times the cosine of theta. If we put that together, we can get cosine theta because we can find u dot v given u and v. We can certainly find the magnitudes. So here's our rule, our dot product rule that helps us get the angle between the two vectors. So here's two vectors I'm going to give you that'll be nice to work with. U is 2 root 3, 2. V is 3 root 3, negative 3. I need to find the magnitude of u, the magnitude of v, and u dot v if I'm going to solve for cosine theta. So first off, u dot v. Multiply the x components, 2 root 3 times 2 root 3, plus multiply the y components, 2 times negative 3. 2 times 3 is 6. Root 3 times root 3 is 3. 6 times 3 is 18. 2 times negative 3 is negative 6. 18 minus 6 is 12. So we have u dot v is 12. But we're not finished. We're going to need to get the magnitude of u and the magnitude of v if we're going to solve for cosine theta. So using Pythagoras, right? X squared plus y squared is hypotenuse squared. The magnitude of u squared, hypotenuse squared, x squared, 2 root 3 squared, plus y squared, 2 squared. 2 squared is 4, root 3 squared is 3, 4 times 3 is 12, plus 4 is 16 is the magnitude of u squared, so the magnitude of u is just 4. And you'll notice the magnitude of v squared is going to behave the same way. Hypotenuse squared is x squared plus y squared, so the magnitude of v squared will be 3 root 3 squared plus 3 squared or negative 3 squared. Frankly, it doesn't matter how you perceive that. The length, though, is 3, and either negative 3 squared or 3 squared both gives us 9. 3 squared is 9, root 3 squared is 3, 9 times 3 is 27, negative 3 squared is 9. So we get 36 for the magnitude of v squared, and the magnitude of v is 6. So u dot v is mag u, mag v, cos theta. U dot v 12 equals 4 times 6 times cos theta. And that will enable us to solve for theta, of course. So we get 12 as 24 cos theta. Dividing by 24, we get a half as cos theta. And what is the angle that we need? When is the cos of an angle a half? When that angle is pi over 3, or 60 degrees. So we found the angle between those two vectors indeed was pi over 3. Let's take a look at another example. This time I have u is 1, 2, and v is negative 6, 3. Their dot product is interesting here. 1 times negative 6 plus 2 times 3. Negative 6 plus 6? The dot product is 0. What does that tell us? Does that tell us something we can use? Well, for kicks, magnitude squared, or hypotenuse squared, is x squared plus y squared. 1 squared plus 2 squared. Magnitude squared is 5, so the magnitude of u is root 5. Similarly with v, either 6 or negative 6 squared gives you 36. 3 squared is 9. 45. Magnitude of v is root 45, which is root 9 times root 5, or 3 root 5. And then we want to go ahead and plug in our rule here. U dot v is mag u, mag v, cos theta. U dot v is 0. Mag u is root 5. Mag v is 3 root 5. But what's happening here? I have 0 equals something times cos theta. Well, if that's the case, cos theta is going to have to be 0. Root 5 is 5, 3 times 5 is 15, but that's not really the issue. The issue that we have here is cos theta is 0, and if cos theta is 0, what does theta have to be? When is the cosine 0? The cosine is 0 if the angle is 90 degrees or pi over 2. And we'll finish this lesson with kind of an important rule, namely, we know u dot v is mag u, mag v, cos theta. If u dot v is 0, if the left-hand side is 0, we're assuming u and v are non-zero vectors because those aren't terribly interesting. So if u dot v is 0 and these guys are away from 0, cos theta has to be 0. But if cos theta is 0, then theta is 90 degrees. And what we say is, we say the vectors u and v are orthogonal, which is the term that we use in vectors to talk about things that are perpendicular. So indeed, the two vectors have a 90-degree angle between them. We say those two vectors are orthogonal or perpendicular. And that will conclude this lesson.